this. So when you guys take your test this week, even though I'm going to give you a practice test tomorrow, these are the basic skills you should be able to do. So let's just practice those. When you get the practice test, you're going to be ready for that. And let's make this a little bit bigger. And when we start a problem with adding and subtracting of decimals, like Michaela said, we're going to line the decimals up. Let's start with that. So even though a problem is written horizontally, you know, that in that direction, you want to rewrite it to add it where you line up the decimals. And it doesn't matter which number goes on top when you add or subtract. I mean, when you add, it does when you subtract. But usually, I think to be safe, you should, I'm going to redo what I just said. You should probably just work left to right. So I'm going to put the 35 in the top. And then I'm going to add it to the 2.103. So when I do that, what would make this a little bit easier? Yeah, Sammy? Yeah, get in the habit of putting a 0 so you have the same amount of place values for addition and subtraction. And then it's a little easier to add. So now I'm just going to add the way we do all addition. I'm going to add 0 plus 3. What do I get? 3. And then I'm going to add 6 plus 0, and what do I get? 6. Then I'm going to add 1 plus 0, 1. Then I'm going to add 2 and 5, 7. And then I'm going to just add 3 plus nothing, so I get 3. And that's my final answer. So, pretty simple addition. It doesn't have any carries, although you might have problems with carries. But just the key to the problem when you're adding and subtracting is lining that decimal up and bringing it straight down. So it's different than when you multiply. Okay. So if we keep with working left to right, let's see, Eric, which number of problem 2 would have to go on the top? Right. And it doesn't have a decimal. So what can I do to make this easier? I could put a 0.00 because this has 2 decimals. So you want to do the same here. It'll just make it easier. And the biggest mistake people make on these problems is they forget that and then they don't borrow. So now I'm going to subtract 32.72. And who could start this? Sarah, what would you do? Yeah, borrow all the way from the 4 and change that to a 3. And this becomes a 10. And then borrow from the 10. So this becomes a 9. And this becomes a 10. Good. Now what? 10 take away 2 is 8. And then 2. Now what? Put down the decimal, right? When you're adding and subtracting, you want to put down the decimal. Okay. 3 take away 2 is 1. 5 take away 3 is 2. That's your answer. 21 and 28 hundredths. You see that, you guys? Okay, Marcos, what should I do on the next one? Which number should go on the top? Yeah, 135.06. So then I need to line the decimals up. So this is 29.169. So now what do I have to do, Marcos? Right. I have to get that placeholder in. Okay, keep going. What happens next? Perfect. I have to borrow from the 6. So I'm going to change that to a 5 and make this a 10. So what do I get here? A 1. What happens here? I have to borrow from all the way over here and make that a 4. And this becomes a 10. Then you have to borrow from the 10. This becomes a 9. And this becomes 15. Good job. That's 9. Because this was 15, right? 15 take away 6 is 9. This is 8. So bring down the decimal. Now what? You have to borrow again. So this becomes a 2 and that becomes a 14. So this is 5. And 0, 1. Raise your hand if you got that right. Great, you guys. So if you got that right, you're ready for the subtraction part of the test. The key is the placeholders. Okay, we're going to pause there and you guys work on the next set of problems. All right, let's go through the multiplies. If you had to use an area model at least once, either problem would work fine. I'm going to do it with this one just to practice a little more. We'll do the traditional with this one, with number 4. So when you multiply traditionally, you usually take the number with the most digits and put it on the top. It's just easier for most people. So 32.7 times 54, and you don't have to line decimals up, which is why I didn't even put a decimal placeholder in there when you multiply. So 4 times 7, what do you get when you do 4 times 7? Yes, Sammy? 28. So carry the 2. Okay, next step, Sammy? Right. 2 times 4 is 8 plus 2 is 10. So carry the 1. Keep going.
3 times 4 is 12 plus 1 is 13.
Good. 3 times 4 is 12 plus 1 is 13. Now what do I do?
5 times 7.
Should I do anything else first? Does this make you think of anything?
Oh, put a placeholder.
Put a placeholder. Right. Now do 5 times 7. So that's the key, is the placeholder. So 5 times 7 is 35. Carry the 3.
3 times 5 is 10 plus 3.
5 times 2 is 10 plus 3 is 13. That's right. Carry the 1.
5 times 3 is 13 plus 1 is 16.
5 times 3 is 15 plus 1 is 16. Now I'm gonna just add. So when I add these up, I get 8, 5, 6, 7, 1. And where is my decimal gonna go? Quinn? Between the 5 and the 8. Perfect. Okay, great. So that's your final answer using traditional multiplication. Now let's practice with the area model on number 5. This always helps you how to do finding areas in general. So if I use the area model, I just break it down like this. Make this 5, make this 4/10. So area model helps me remember how to break things down into expanded form. So 3 times 5, 15, right. Okay, Nick, what about 3 times 4? That would be 12. So 3 times 4/10 would be what? 1.2. Perfect. Okay, how about 6 times 5, Nick? 30. So what about 6/10 times 5?
30.
Right. And then 6 times 4 is? Keep going. What's 6 times 4?
28.
Close. 20. Haley? 24. And then there's 2 decimal places, right? Perfect. So you have to put the decimal in front of the 2. So I'm going to add 15 and 3 in my head, and I get 18. And then I'm going to put a 0.0 because I'm doing addition now. I'm going to line up all of my decimals. So now I'm going to add 1.2. And then a 0.24. So you might have seen I put in 2 zeros. If I have 2 decimals here, I'm going to go ahead and fill in place values there. And then I'm going to add. So I get 4, 4, decimal, 9, 19.44. Did anybody get that answer? Okay, good. Any questions? Alrighty, so that's that one. Let's do these. So these are all mental math problems. The key is thinking about what happens when you divide by a number bigger than 1 or less than 1. So on this problem here, since this is smaller than 1, when I divide by something smaller than 1, my original number is going to get bigger by 2 powers of 10, because this is tenths hundredths, so this is 1/100. That's 2 powers of 10, so this gets bigger. So we take our 76, we put a decimal in, and we make it bigger by 2 powers of 10. So we get 7,600. Okay? Does that make sense? This problem's a little bit different. This is where you might think about those fact families from elementary school. We know that 4.6 times 10 is 46. So therefore, if I go 46 divided by 10, I'm going to get 4.6. And if I do 46 divided by 4.6, I'm going to get 10. You always get one of the numbers in the fact family. So this is 10. How many people got that? So about half the class. So that would be one if you don't have to study. You want to practice those fact families. I'll give you a few more of those tomorrow. Okay. Andy, when I do this problem, 128.5 times 1,000 is the original number. 128.5 going to get bigger or smaller? So I multiply by 1,000.
Bigger.
Which one? Bigger, right. Right. How many powers of 10? Good. 3. So you take your 128 and 5/10 and you make this bigger by 3 powers of 10, which is the same as moving the decimal 3 times. And when we have blanks here, we put our decimal there. What do we have to do in those blanks? Add zeros. Right, so you have 1, 2, 8, 5, 0, 0, because you put the 2 zeros here. So your final answer is 128,500. A lot bigger, isn't it? Number 9. Marcos, how about this one? When I take 3.56 and I multiply it by this tiny little number, is 3.56 going to get bigger or smaller? Smaller, right. Good job. By how many powers of 10?
3.
Perfect. By 3 powers of 10. So we take the decimal then, And we get smaller, so we're gonna go 3 powers of 10 to the left. And put our decimal. So what do you have to do, Marcos?
Add 0.
The only one zeros. So you have 0.00356. Who can say that number? Yeah, Isabella, what is it? No? Well, tens, hundreds, thousands, tens, thousands, 100,000s. So Cannon? Yeah, 356,000,000. Almost millions, but not quite. Okay, let's see, who haven't I called on today? Haley, you want to do this one? Will this 8.9 get smaller when I multiply by 1/100th, or is it going to get bigger? Smaller by how many powers of 10? 2, right? Tens, hundreds. So you're going to take your 8.9, make it smaller by 2 powers of 10. So what do I have to do, Haley? Put a 0 in. So 0.089 is your final answer. And then the last one, Mark, real quick, what's the last one going to do? Smaller or bigger?
Smaller.
By how many powers of 10? 4? 3. Okay, guys.